let's take a look in code and see what that looks like. So let's say I have this class called CLPet. Okay, that's just a basic generic pet. And when we played around with the ePet sandbox assignment, this is the class we created. And you can see that CLPet has a few things that it must do, right? We must give it a name in a string fashion, and that becomes str pet name. And then when it's created, it sets hunger and boredom to 5. And right now, the type is just a generic animal type. So if I wanted to, I could create a class called CLFish, right? And if I wanted that fish to be based on the CLPet class, what I would do is I would put that CLPet inside the parentheses. So basically what I'm saying here is I'm creating a new class called CLFish, and I'm basing it on CLPet. That is the parent class. So right away, already before I do anything else, we know that CLFish is going to inherit all of these things. CLFish will have all of those properties: hunger, boredom, a name, and a type. Now, one thing that I'm going to need to do, because CLPet requires in its initialization a parameter, I've got to give that parameter when I instantiate CLFish, or else I'm going to get an error. So what that means is I have to have an initialization class, and I have to give it a name as a string. And then what I have to do when I create CLFish is I have to call the initialization class or the initialization method of the previous class or the parent class. So the way I do that is through the use of a keyword or a function called super. And super, anytime I type the word super in a child class, what that means is I'm referring to the parent class. And you'll notice already the methods and properties of that parent class are showing up. So it knows that connection is there. But what I'm going to do is I'm going to call the super class's initialization, and I'm going to give it str name. Okay, so when I initialize the fish, I'm going to give it a name, and then I'm going to pass that name directly to the super's initialization class, because in order to create a child based on that parent, I need to call the initialization, or else I'm going to get an error. So the rest of these are already going to exist now. So the name, hunger, boredom, and the type from the parent class will be inherited here, even though I don't mention them at all. Let me show you. So if I say my fish equals CLFish, and I want to name it Guppy, what we'll see is my fish dot type. Let's print the type. Print type. There we go. Let's run this and see what it does. Okay, so I printed the type, and it's just animal right now, which is fine. Fish are animals. But I want to show you something, because it's not exactly perfectly clear when I run this what's happening. But what's happening is when I create the fish, when I create an instance of fish, this initialization method runs. And inside this initialization method, we are manually triggering the initialization of this. So when I say this, print creating a fish. And if I print this, creating a pet. So if I run this, watch what happens. So notice that it's printing both of those things because it creates both of those things. It creates a pet and a fish. In the process of doing that, it's running both of these. So it's like you're creating the CL pet, and then you're adding on to it whatever's there for the CL fish. And that's useful for a lot of reasons. This scenario is one of them.